Hi guys, welcome to today's class where we'll be looking at another example under the closure property. So we'll be taking it, so I want us to actually follow through because this will be getting a little more technical than the previous one. But let's look at this. In this question we have an operation, a particular operation that was given here. Said the operation is defined by x operation y equals to x minus 3xy. Now we are asked to determine whether the operation is closed under set z plus containing positive integers. The z plus there is just indicating that was for z. Anytime we talk about set z, we know set z means integers. So z plus in this case means positive integers. So that is what we're using to define the set in this case. And then we are asked to determine if this operation x operation y, which is given as x minus 3xy, we are asked to determine if this operation is closed under set z. Set z plus is what? Positive integers. So before we even say we want to start considering or not, we need to first understand what are the elements inside or the elements in the set z plus. That is, what are the elements, what are the examples of positive integers? We know integers are basically whole numbers. So when we talk about positive integers, we know we are talking about positive whole numbers. Like 2, like 3, like 4, in fact from 1 upwards. As far as you're an whole number and you are a positive value, then you are a member of the set z plus. So if all I need to do here is take two elements out of the many elements of the z plus set, take two elements and then apply them and then see if it will be a closed, if this property will be, if this operation will be closed under the set z plus. Now, so let's here we can say what? Let's say okay, we have this operation under set z plus containing positive integers. So we have set z plus containing positive integers, and then we want to know if this operation is closed under set z plus. So all we need to do here, we can say pick two values for x and y. We can say let x, for positive integers we can use 6. You know 6 is a positive integer, and then we know for our second value we can pick 10. These are also, we can pick any positive integers we like, but in this case we're just using 6 and 10. And let's see how it plays out. So now, for this operation, I can say for x operation y here, my x operation y here can now be referred to as 6 operation 10, which will now be explained as what? As from the formula above, you know we have x minus 3xy. It means that what? For any time we see our x, we'll be representing it with 6, and anywhere we see our y, we represent it with 10. So we have 6 minus 3 times 6 times 10. So trying to work this out, I have 6 minus 3 times 6 here will be giving me 18. 18 times 10 will be giving me 180. So subtracting this, I'll be having my x operation y to give me a value of minus 150, minus 174 rather. So I've gotten my value. All I need to do now is to determine, is this operation closed under the set z plus? Is this value a positive integer? Because we know that what it has a negative sign, although it is still an integer because it's a whole number, but this is a negative integer. So this is not a member of the z plus set. I'll say what? Since minus 174 is not an element of set z plus, then the operation this is not closed under set z plus containing positive integers, because we know the value we are having here is a negative integer. So because it's a negative integer, then it cannot be a member of the set z plus. So by that inference, we can now say what? This operation is not closed under the set z plus. So in the next class, we'll be taking another example. We'll be going further into the idea of closure property and how we can actually apply it. See you next class.